All right, this next section we have 4.3, the mean value theorem, and something called monotonicity, or the property of a function being monotone. Um, so, first let's talk about the mean value theorem. So the mean value theorem, its statements right here. Essentially, the hypotheses are that we have a function. That function is continuous, and it is defined on it's a continuous function on a closed interval, and it is differentiable on the open interval. This is really a technicality. It's not that it has to lose differentiability at the endpoints. It's that really, if you only are considering a function on a closed interval, so you are essentially putting blinders on to everything outside of this range of real numbers. So you're really only looking at a function like this, where we have our axis, here's A, here's B, and sure, the function might continue on elsewhere, but we're only assuming, or we're only looking at it in this one little window. So since differentiability has to do with the slopes of the tangent line as you approach a point from the left and from the right, in the middle here of this graph, we can approach from the left and see how the tangent lines are approaching this tangent line, and we can also approach from the right and see how the tangent lines are approaching that tangent line. So we are actually able to perform a left and right hand limit of slopes, of secant lines, to see how those slopes change, where at the endpoints we can only do a one-sided limit. We can't actually do a left-hand limit at the left endpoint because there is nothing to the left that doesn't exist in our interval. So the fact that differentiability is only required on the open interval is really more technicality, as if you have got a function, it goes on forever, and then we only look at it at a certain window, we can really only talk about differentiability in the open interval, because then we would have a left and a right on either side of every point within the open interval. So don't really worry so much about this. It's a technicality, but that's why it's there. So essentially, if we have a continuous function and it's differentiable, then the mean value theorem says that you can find there exists some value c that's neither a nor b, somewhere in the middle here, where this right-hand side is, of course, our familiar average rate of change. I'll just abbreviate that ROC for rate of change. This right-hand side is the slope of the secant line, which we should know by now represents the average rate of change on the interval a to b. So it's the average rate of change on the interval a to b. Where the right-hand side here is saying the instantaneous rate of change. Of course, this is the slope of tangent line. So effectively what the mean value theorem says is take any little interval on your graph. So if you've got a graph, it's differentiable, just take a look at a portion of it, maybe like right here. So if we look at this portion of it, there's our portion. If we draw the secant line from one point to the end point, there is at least one point in the middle where the tangent line is parallel to this secant line. And we can see it would be right there, and also another one right here. So there's actually two locations that are neither of the endpoints. They're in between. There's at least one location where these tangent lines are parallel to the secant line. Now, because it says there exists, that doesn't mean there's only one location, but there is at least one location. So another way we can rephrase this in terms of, for instance, maybe we're driving a car, so we could say something like, if you drive, let's say, 2 hours and travel, let's say, 140 miles, then your average velocity is, of course, 140 divided by 2, which is 70 miles per hour. And since velocity is a differentiable quantity, we know there was a moment during our trip where we were traveling at exactly 70 miles per hour. So if our average velocity over the two-hour trip was 70 miles per hour, then there was at least one moment in time where our speedometer on the car read exactly 70 miles per hour. Okay. And that's essentially what this says right in here.